The learning target for today is I can evaluate nth roots and rational exponents without a calculator. To review the previous lesson, an nth root of a can be written in this form, where a is the radicand and n is the index of the radical. And also, regarding the previous lesson, the nth root of a can be written using a rational exponent as a to the 1 over n power. Now what we're really going to start to talk about today are the real nth roots of a. And depending on the value of your index and the value of your radicand, that will help you determine the type and the number of nth roots you will actually have. If you look down here in the core concept box, this is a nice summary of what we'll be talking about. It says let n be an integer greater than 1 and let a be a real number. If n is an even integer, in other words, if your index is an even number, like square root or fourth root or 10th root, there are three situations that can arise. If your radicand is less than 0 or negative, there will be no real nth roots. We would have to introduce an imaginary unit to be able to get an answer for this. If your radicand is equal to 0, there will be one real nth root. The nth root of 0 is always going to be 0. If your radicand is positive, or your a has a value greater than 0, there will be two real nth roots, a positive root and a negative root. If your index is an odd integer, like cube root or 7th root, three situations could arise. Notice they all look similar, but we'll talk about what the difference is. If your radicand is less than 0, you will have one real nth root. If your radicand is a negative value, then your one real nth root will also be negative. Again, if a is equal to 0, you will have one real nth root. That will be 0. If a is positive or greater than 0, you will have one real positive nth root. So if we look down here, it says find the indicated nth root or roots of a. The first problem, notice we have an index of 2 and a radicand of 81. This is an even integer for our index and a positive value for our radicand. We will have two real nth roots. This is asking us to find the square root of 81. We could have roots of positive or negative 9. Now example number 2, notice we have an index of 3 and a radicand value of negative 64. This is an odd integer for your index and an a value of less than 0. We will have one real negative nth root. This is asking us to evaluate or to find the cube root of negative 64. And the cube root of negative 64 will be negative 4. Example number 3 gives us an index of 5 and an a value of 243. That is an odd integer for our index and a positive a value. We will have one positive real root, and the fifth root of 243 is 3. Now, if you recall from the previous lesson, rational exponents are not always just going to be 1 over n. You may have values like 3/2 or negative 1/2. So we may need to look at our rational exponent rules again. If you have a rational exponent where it's in the form a to the m over n power, that can be rewritten as the nth root of a to the m power. And when you're simplifying rational exponents, it is actually easier and simpler to do if you do change the rational exponent to radical form. Another rule we need to remember is if we have a raised to a negative exponent. Remember, the negative part of an exponent really just means the reciprocal of. So I would take care of that part first and then switch to radical form. Now, when it comes to simplifying radicals or rational exponents, the one thing about the number and the type of roots you will have is when you are simplifying or evaluating, find only the root that's implied in the original problem. For example, what I mean is, we know that square root would be an even index, and with a positive radicand, we should have two possible real nth roots. However, look at the problem that they're asking you to simplify. If they want the negative square root of 4, the answer would be negative 2. If they want just the square root of 4, that would just be 2. The way I kind of remember this is if it gave me the radical, I'm going to give the root that matches that radical. when it comes to solving in future lessons, when it comes to solving equations using roots, if you introduce the radical to the problem, then you do have to include both of those real roots because you don't know which one the problem is actually going for. So for these examples, I am going to assume that they only want the root that is implied by the original problem. For example, this first one is the 6th root of 64. I see that there is no negative in front, so I'm going to assume they only want the positive or the principal root, and the 6th root of 64 is 2. Example number 2 is written in rational exponent form. I am first going to start by writing that in radical form, and this would be the square root of 16 raised to the 3rd power. The square root of 16 is 4 to the 3rd power, and 4 to the 3rd power is 64. Number 3 is in radical form. Again, think through your order of operations. Work what's inside first. The cube root of negative 27 is negative 3. And then we need to raise that value to the 4th power. And negative 3 to the 4th power is 81. Now, if you look at example 4, notice that you have a negative exponent. Remember, the negative part of the exponent just means the reciprocal of. So I'm first going to rewrite this as the reciprocal of the 5th root of 32 to the 2nd power. Now I'm going to simplify the radical that's in the denominator. The 5th root of 32 is 2, and 2 to the 2nd power will give me a final answer of 1 over 4. Example 5 is similar. Notice you have a negative exponent, so that just means I need to find the reciprocal of 64 to the 2/3, and then I will then rewrite this in radical form. That would be the 1 over the cube root of 64 raised to the 2nd power. The cube root of 64 is 4, and 4 raised to the 2nd power will give us a final answer of 1 over 16.